Okay. Hope you had a really good spring break. Right now, you guys finished the test, so we are hopping into the next unit, which is factoring. Factoring is a pretty difficult unit. We're going to start with finding GCFs and factoring out GCFs, and it's going to get increasingly harder along the way, so make sure you're coming on to our sessions for help. So what is a GCF? A GCF is a greatest common factor. So what that means is you want the biggest, right? This is the biggest thing that's in common that's also a factor. And a factor, remember, are two things that multiply to each other. So if I'm thinking about the number 4, factors of 4 would be 1 and 4 and 2, because 1 times 4 is 4. Okay, I'll write that down. 1 times 4 is 4, and 2 times 2 is 4. So my factors of 4 are 1, 2, and 4. Okay, that's what the word factor means. So we want the biggest thing that's in common between the numbers. So there's a lot of ways you can do this. I'm going to do it a specific way because I found that has been successful for a lot of the students that I teach. So that's how I'm kind of going to tackle it. Some people will use factor trees. That is one way. I don't use factor trees, but if you want, I'm going to link other videos that can help you, and you can look at that method if this one is confusing. So 18, I'm going to list my factors of 18. So that's 1 and 18, 2 times 9, 18 divided by 3, 3 and 6. If I try 4, I don't get anything. It's not a whole number. If I try 5, it's not a whole number. If I try 6, I get 3 again. That means that's all the factors. So when it loops back and you get back to the right side, that means you can stop. So if we try it with 54. So I get 1 and 54. And then if I divide by 2, I get 2 and 27. Sorry. If I divide by 3, I get 3 and 18. Okay, sorry guys. I had to just pause it. My dog was itching me to go out. Okay. So we left off at 3 and 18. So 54 divided by 4, not an even number. 54 divided by 5, not a whole number. 54 divided by 6, I get 9. So 6 and 9. 54 divided by 7, nope. 54 divided by 8, nope. 54 divided by 9, 9 and 6. I already have that, so I'm done. So now I want to look at the greatest common factor. Okay, so I want the greatest common factor between these. Well, yes, 2 is on both lists. 1 is on both lists. 3 is on both lists. My suggestion is to go to the lower number. So in this case, it'd be 18. And you look to see if the biggest one is over here. If you start small, you might not realize that there's a bigger number. So in this case, if I start with 18, 18 is over here, so it's 18. The reason why I said to start with the smaller number over here, so 18 instead of 54, is because if 54 will have bigger factors, since it's a bigger number, that 18 can't have. So if you start with the smaller of the 2 or 3, however many you're doing, and you go down from the biggest, you'll be able to find the greatest. Remember, 2 is a common factor, 3 is a common factor, but it's not the greatest. Okay, now example 2 just is the same idea. It just now also has some letters. So we're going to do the same thing. First, find factors of the numbers. So 1 and 4. If I divide 4 by 2, I get 2 and 2, but I get right back to 2, so that's it. Now for the x's, x to the third means that I'm doing x times x times x. So what I'm going to do is just put x, x, x. So I'm going to list it out. That's what that means because there's 3 of them. For 6, the factors are 1 and 6, then 2 times 3. Then if I were to try 3, I'd get back to 2. So I'm done. And now I'm going to put 7 x's. Now, eventually, you might be able to do this without even writing all the x's, but for now, this is the process I'm going to use. So when we're trying to find the greatest common factor, we want a number and however many variables. Well, so I go to the smaller of the two, 4 and 6. So I look at 4. And I say 4. Is 4 on this list? No, it can't be 4. 2. Is 2 on this list? Yep. So it's got to be 2 because that's the next smallest number. So that means I circle the 2's and I can write down 2. Now x's. Which one has the smaller x's? The third. If I circle all 3 x's here, are there 3 over here to circle? Yeah. So that's how many they have in common. X to the third. Now, if I tried to accidentally messed up and I circled all 7, can I circle 7 over here? No. So that means they don't have that in common. You can only circle the smallest amount of the variable. That's the most they have in common is the one, whoever has the smallest. Same thing, whichever number is smallest is the one you start with. Same things with the letters. Okay. I originally was going to do another one, but I'm actually going to just go to example 4. I'm going to skip example 3 because I think you guys can do it. Okay, so for this one, these numbers are pretty big. This is where you're going to want a calculator. And you literally are just going to take your calculator, and I'll zoom out so you can see mine, because I don't know the factors of 102. Okay, I have no idea, and that's okay. I don't expect you to know them. Let me make it so it's clear. It's a little better. Okay, so I'm going to do, obviously, 102 divided by 1, so 1 and 102. 102 divided by 2 is 51. I'll try by 3, which, if you remember how to tell if things divide by certain numbers, you can skip. 102 divided by 4 does not work. Now, 5, I should know doesn't work because this isn't in a 0 or 5. Try 6. 6 and 17. Okay, try 7. Okay, nope. Try 8. Nope. Try 9. Nope. Try 10. Nope. 11. And I'm going to keep going until I get back to a number that's on my list. Now, I could have known to stop already, but just in case. And I try 17, and 17 and 6 is already here, so I'm done. Now, this has multiple variables, so now I just have to put 2 A's, 3 B's, and when there's no exponent, remember that means 1, so I just put 1 C. Okay, I'm going to do the same thing for 85. Sorry, I got to move this over a little bit so I can write. 1 and 85. 2 shouldn't work because it's not even. Try 3. 5 and 17. Okay, oops. See how you're at 9 and it went back to 9? If I keep going, it's going to now go to numbers that I already tried, like 8. And if I keep going, it's going to go to 7. Well, I already tried all those, so that's another way to tell to stop. But if you keep going, when you get to 17, it's going to give you back 5 and you're done. So either way, you can stop whenever. Okay, and now I'm going to just list 1A and 2 B's. So when I'm trying to figure out the greatest thing they have in common, I go to the smallest number, sorry. So not 102 is 85. I start with 85. Is 85 over here? Nope. Is 17 over here? Yeah. So I'm circling my 17s. That's what they have in common as the number. Now I go to my letters. Well, this one has 1A. This one has 2 A's. So the most they have in common is 1. So it's just A. This one has 2 B's. This one has 3 B's. So the smallest amount is 2. So B2. This one has no C's, and this one has 1 C. So do they have any C's in common? No, I can't circle this because I can't circle a C over here. There's no C. So my GCF of this one would just be 17A, B to the second. So what we just did was we just noticed what the greatest common factor is. The second part of this lesson is now, once you know what it is, undoing the distribution and figuring out what's left. So that's the second part that we're going to talk about now. Okay, in order to help you, I'm going to give you some steps in solving these. So now we did what is a GCF. Right now we're going to talk about factoring using the GCF. And I'm going to give you some steps along the way. The same thing's going to be true. So we're going to look at example 1. And what we want to do, okay, here's my first step, is we want to find the GCF. And that means we want to find both the coefficient and the variables. So we want both. Sorry, you couldn't see that. Coefficient and variables. Let me just turn this a little for you guys. There you go. So if I look at example 1, I'm going to do the same thing. So 1 times 4, 2 times 2. Sometimes you shouldn't need the calculator, and I'm going to put an X. Now 8 is 1 and 8, and 2 and 4. So if I use the same rules, if I go to my smaller number, the biggest number is 4. Is 4 over here? Yes. So I circle 4. Now this has an X, but does this have an X? No. That means they do not have an X in common. So their only thing they have in common is a 4. And sometimes that happens. Now the second step is to divide each term by the GCF. Now that's actually what you're doing, because like I said before, you're undoing the distribution. But what happens is you also can figure out what's left based on kind of what's here, which is why I have students do this. When you divide each term by the GCF, you put the remainder inside parentheses. So every time you factor out a GCF, you then have parentheses, kind of like the same size as whatever your equation was or expression, and you fill in what's left. So if I do 4 divided by 4, I have 1. X divided by nothing, well, I didn't do anything with the x's, so I just bring it down. Negative 8 divided by 4 is negative 2. Now the cool thing about what I have you guys do is, if I look at this, well, if I circled the 4, what goes with the 4? The 1, right, which is here. The 2's didn't matter, and then there's an X left over, so the X goes inside. Now I circled the 4 over here, and what was left? The 2, so the 2 came here, and I brought down the sign. So really, if you follow this method too, you can see what's left just right next to whatever you circled. So whatever is not in the circle is what ends up inside the parentheses. So this is now factored. It's 4 times 1x minus 2. Okay, let's look at example 2. Example 2 says b squared plus 4b. So there's technically an imaginary 1 right here. So if I list factors of 1, well, that's just 1 and 1, and that's it. And if I list b twice, because there's 2 of them. Factors of 4, 1 and 4, 2 and 2, and a b once. So again, I go to my smallest number, which is 1 compared to 4. The only thing I can circle is 1. So if I circle a 1 over here, I circle a 1 over here. This has 2 b's, this has 1. So the smallest amount of b's is 1. So I circle 1 here, circle 1 here. What you found goes on the outside. And then you have to divide to figure out what's left. So 1 divided by 1 is 1. V2 divided by V. Well, if I had two v's and I took one, one's left, which is right here. One v's left. Plus 4 divided by 1 is 4. And v, and I took out a v, there's no v's left. That's it. So here, if I look, the 4 is not circled, which is why it's here, but the v is circled, so there's nothing that can go here. So this 1v times 1v plus 4 is my factored response. Okay, seeing where I'm at time-wise for you guys, I don't want to keep you too long on here, so what I'm going to do is jump to example 5, 6, and 7, and that's going to be it. I'm trying to give you guys ones that look different, just so that way no matter what questions you're given, you can answer them. So here we go. We're going to do the same thing. We have to find that GCF. So I'm going to list out my factors of everything. 1 and 10, 2 and 5, and this one has 3 x's. 25. 1 and 25, 5 and 5. And this one has 1x. 20, 1 and 20, 2 and 10, 4 and 5. You're going to get good at these, and you're going to, kind of like I just did, you're not going to have to use your calculator. But for now, you can use your calculator and divide. So now I'm looking at the smallest number, 10, 25, 20. So the smallest is 10. So it's 10 on every list. It's on this one, not on this one. So 10 does not work. 5's here, 5's here, and 5's here. So my GCF coefficient, my number is 5. So I'm going to put a 5 down. Then I look at the variables. I have 3 x's here, 1 x here, but I have no x's here to circle. So I can't circle one because this I could circle one and this I could circle one, but I can't circle anything here. That means the only thing they have in common is 5. So now I use that divide and fill in what's left. 10 divided by 5 is 2. Did I take any x's? No. And how many did it have? It has 3, so I have to put x3. 25 divided by 5 is 5. And they had an x, and I didn't take any. There's an x here, not circled, so it goes here, and that's a negative. Plus 20 divided by 5, which is 4. Now, again, if you look at where I circled, here's the 4 right next to it. Here's the 5 and the x that are hanging out. Here's the 2 and the x3. So, because these, technically, these are the matches we didn't use. And you can look at it like that, too, instead of dividing. Now, if I distribute back, that's how I can check. 5 times 2 is 10, x3. 5 times negative 5 is negative 25x. 5 times 4 is 20. And that's how you know you're correct. Make sure you're pausing along the way to copy everything. I'm trying to move a little fast just so that way the length of the video isn't so long. All right, we're going to do it again. Find the greatest common factor. So 1 and 30, 2 and 15, 3 and 10, 4, no, 5 and 6. Now this one's kind of a long one. It's got 7 x's. I'm going to put them over here. And 3 y's. 27. 1 and 27. 2, no, because it's a 7. 3, yeah, 3 and 9. 4, no. 5, no. 6, no. 7, no. 8, no. 9, back to the beginning. 3 x's and 3 y's. So I go to the smallest one out of 30 and 27 is 27. 27, not on the list. 9, not on the list. 3, on the list. So I circle my 3's. That's going on the outside. Okay, this has 7 x's. This has 3 x's. So I go to one of the smallest. So I circle all 3 here. So I can circle 3 here. So that's good. x3. Smallest y's. Well, this has 3 and so does this. So it's just y3. Okay, now what's left? I'm going to use the other way. So I didn't use these factors. I'm going to cross out the factors I didn't use. So out of this one, I chose 3, so 10's left. What's not circled? 1, 2, 3, 4 x's. Are all the y's circled? Yeah. Does that mean? That means there's nothing left here. There was y3's, but I have y3's here, so I don't have any here. And the same thing. I use 3, so 9 is left. And, oh, all my x's are gone because there's x3 out here, and I had x3. And I have y3, and there's y3 out here. There's no variables left, so that's it. So this is my answer for this one. You will get better at this the more that you do. Okay, we're going to do one more. I'm trying to make them, again, look different, and then that's it. All right, so hang tight. You're doing a great job. Here's the last one. This one is a trinomial. There's 3 of them. So I'm going to have to list 3 different things. Okay, 1 and 20, 2 and 10, 4 and 5. And I list out 6 x's. 1 and 12, 2 and 6, 3 and 4, and I'm going to list out 4. 1 and 18, 2 and 9, 3 and 6, and I'm going to list out 2. Smallest number here is 12. 12 is not on the list, so that one is gone. 6 is not on the list. 4 is on this list, but not this list. 3 is on this list, but not this list, so no. 2 is on this list, and this list, so it's 2. That means all the other pairs are gone. I don't use them. So I'm putting a 2 on the outside. Go to my smallest x's. This has 2, so I can circle 2 here. I can circle 2 here. I can circle 2 here. So that means 2x2 is on the outside. So if I now try to figure out what's left, 20 divided by 2, or what's the pair with 2 is 10. I had 6 x's. I took out 2. Or how many are not circled? 4. 12 divided by 2, or what goes with 2? 6. I had 4 x's. I took out 2. Or how many are not circled? 2. I took 18 divided by 2 is, or what goes with 2? 9 is next to it. I took out 2 x's and I had 2 x's, so no x's left. So there's my final answer for example 7. Please let me know if you have any questions. Reach out to me on Remind, reach out to me through email, whichever form of communication works best for you. And come on our class sessions if you need any help.